Okay, we talked about inequalities in one triangle. Now we're going to talk about inequalities in, guess what? Two triangles. Very good. All right, so let's do this. All right, there's a triangle right here. Everybody paying attention? Shh, a lot of talking going on. Let's do this. And let me, probably should have done this before, but that's okay. Watch, I'm going to keep everything, watch what I'm going to do. I'm just going to twist this right here. Everybody see what I just did? I kept that length the same. You guys paying attention, right? I have started. Okay. So I took this length right here. I copied and pasted this triangle. I took this length right here, and I just scooted it over. I didn't change the length of it or anything, all right? So this length and this length is still the same. This length and this length is still the same. But in order to make a triangle now, I'm going to have to take this one, and I'm going to have to change the length of it, aren't I? And move it around like this. So let's see what I have so far. Remember, I kept this length.
Sorry.
Oh, it's okay.
You need to have
Okay.
this.
All right,
Jimmy's
thanks.
sick.
Okay. I got this length and this length the same. I've got this one right here and this one right here the same. Now this one is different than this, isn't it? Did you see that? Because I copied and pasted. All I did was take this side and just kind of rotate it. I didn't change the length of it. I just rotated it so it's at a different angle. Then I took that third side, which was this one, and in order for them to match up to make a triangle again, I'd have to take this and stretch it out to here, didn't I? Okay, so see what I have so far. I've got this length equal to this one, so that's one side equal to another side. I've got a second side equal to this side. So far I've got two equal sides, don't I? But look at this side right here. This side right here, I'll put 3 marks. I'll put 3 little tiny marks here, and watch what I'll do here. They don't do this in the book. I just do this. Now, why did I make these a lot bigger than this? Because this side is what? Bigger than this side. Does that make sense? Okay, I put 3 here. They're not equal to each other. Just because they have 3 marks doesn't mean they're equal to each other. But this angle, or this side, not angle, this side right here is smaller than this side right here. You with me on that? So, if I have, let's see, let's see what I want to do here. I just want to make sure that I do the right one because there's a couple different ones here. Yeah. Okay, so watch what I have. What I have, I got 2 sides that are equal, and then I got one side that's not equal. So these 2 sides are equal to each other, and this one right here is not equal. So I don't call this the side-side-side theorem like we did, or postulate. Do you remember we did that way back? We did side-side-side, side-angle side, and all that kind of stuff. So this isn't side-side-side where they're exactly the same, because this side and this side are not the same, are they? These 2 are, this one's not. So I call this the side-side-side inequality theorem. Now the book doesn't call it this. Now how did I get this? Well, I taught out of other books before, other geometry books, and almost every other geometry book uses this as the name for the theorem. They call it the side-side-side inequality theorem, which means what? It means 2 of the sides are equal. Do you see it? Or 2 pairs of the sides. This side and this side are equal. That's 1 pair. This bottom one and this bottom one right here, they're equal. That's 2 pair. You got it? But what about the third one, though? The third one is not equal, is it? All right, this one is smaller than this one. If we have a situation like that, let's take a look at the angle. Let's take a look at this angle that's opposite the smaller side, and let's take a look at this angle right here, opposite the bigger side. What do you think is true about this angle compared to this angle right here? It's smaller, that's right. And it's smaller because it's opposite which one? The smaller side, that's right. So the smaller, look at the angle opposite the smaller side, that has to be smaller than the angle opposite what? The bigger side, okay? So if I gave you this information and I said, let's label these so we have something to refer to. A, B, C, D, E, F. So if I said that AB was equal to DE, that's 1 pair of sides equal. BC was equal to EF, that's 2nd pair of sides equal. AC is not equal to DF, right? This is smaller, so they're not equal. It's still three sides that I'm given, but I'm given two sides that are equal, one side that's not equal. That's why I call it inequality. Everybody with me? All right. If we have that situation, then what can I say about the angle? Look, the angle opposite the smaller side is going to be smaller than the angle opposite the bigger side. Everybody see that? Okay. And then you can tell me. So what could I, just by this information right here, what could I say? I could say that angle B is what? How would I write it? I don't write the word smaller. How would I write it? Less than what? Angle E. And that's how you would write it. Make sense? And why is that true? Because of what? The side inequality. Now remember, all three sides are not equal to three sides of the other one. Two are equal, right? Two pair are equal. The other one is unequal. That's why we call it side inequality. Make sense? These triangles are not congruent, are they? No, absolutely not. They're not congruent to each other. So it's not just side postulate like we did a long time ago, but it is a side inequality. So I've got two triangles. I'm not just comparing one triangle. Remember yesterday we just looked at one triangle, even the day before we just looked at one triangle and we saw, which one was bigger, which one was smaller. Now we're comparing two triangles to each other, comparing this one to this one. All right, they call it the side inequality. Now the book calls it this, just so that when you see it, you'll oops. Okay, I got to grab that thing. There it is. Let's put it right there. They call it this. They call it the Hinge Theorem. Like a hinge on a door, right? It makes the door swing in and out like this. Okay? The door doesn't change size, does it? As you move the door in and out, the door doesn't grow bigger and it doesn't get smaller. All it does is change directions. You see that? So watch. It's kind of like this. That side right there is not getting bigger or smaller, is it? Okay, what it's doing is just on a hinge. Do you see it? So that's what we're doing. We're just saying, okay, let's take one of these sides. Let's not change the length of it, but let's just move it around like this, like it's on a hinge. Make sense? All right, that's why they call it the Hinge Theorem. I kind of like this better, all right, because it tells me that if I have two sides that are equal to two sides, one side that's not equal to another side, then I can say something about the opposite angles. Remember, I can only talk about the opposite angles, right? Opposite the small one is smaller than opposite the big one. Or you could go the other way around, couldn't you? You could start with angle E. What would I say? I would say angle E is what? Greater than, right, angle B. Either one of those means the same exact thing. You see that? You could read, on inequalities, you could read it from right to left, couldn't you? Because watch, if I read it from right to left, angle E is what? It's going in this direction. See how it's bigger here and then smaller here? So if I read it from right to left, pretend I think Chinese read right to left, don't they? Okay, so watch. Angle E is what? Greater than angle B. Or if I read it from left to right, angle B is less than angle E. Right? It means the same exact thing. Does that make sense to you? For instance, if I said 3 is less than 5, isn't that the same thing as saying 5 is greater than 3? Yeah, same exact thing. So just kind of get used to looking at it both ways like that. We good with that? Okay. We got another one of these. It's actually, I think it's the converse of it. Hold on, let me see. Okay, here's two triangles. What I'm going to do, it's kind of the same thing. It's just a little bit different. Watch. Let me ungroup this so I can take one of the sides. Now what I'm going to do here is, let's do this. It's kind of the Hinge Theorem again, except the information that's given is a little bit different. Watch, I'm still going to swing this up like that. I didn't change the length of that, did I? No. All right, see what I'm doing? I'm just swinging it around, swinging it around. Isn't that cool? All right, so I didn't change the length of it. All I did was change that angle. See it? It was this. Now it's a lot bigger, isn't it? You see it? But in order to make a triangle, what am I going to have to do to this side? I'm going to have, well, not just swing it, because if I just swing it around, it won't reach up there, will it? I'm going to have to change the size of it. And it looks like exactly the same thing that I did before. But the information is going to be a little bit different. All right? I didn't quite hit that exact, but that's good enough. You're okay with that, aren't you? Watch. Look at the information. What did I not change? That one and that one stayed the same, didn't it? Okay? This one down here at the bottom and this one down here at the bottom, that stayed the same. It was this length right here that I changed. Remember I took that and I had to make it a lot bigger and it turned into this one. So look at the information though. When I did that hinge thing and I moved it around like this, I changed the angle, didn't I? So watch. I've got an angle. I've got a what? I'm sorry, an angle. I pointed this as, thank you. I got a side, I got an angle, and I got a side. But are those two angles equal to each other? No. So I would call this the side angle side what?
Inequality.
Inequality. Very good. You guys are following along. Quality. Okay? So I call the side angle side inequality. Now, the two sides are equal, right? This side's equal to this side. That's one pair of equal sides. Here's another pair of sides that are equal to each other. But what's unequal in this? The angle. Okay, that angle is unequal. This one is smaller than this one. So let's do this again. I'll tell you what, let's use different letters. Somebody give me some KFC. All right. And give me another one that don't have these same letters. What? FBI? FBE? We can't use F because we used the F over there already. DSH? What's DSH? Huh? Oh, it's yours. I thought it was Eric because I just heard it coming from that side. I never hear you say anything, Daenerys. That's why. DSH. Okay, good. That'll work. All right. So, all right, let's take a look. So what do I have now? I know that FK is equal to SD. I know that FC is equal to SH. But I also know that angle F, I'm given that angle F is what to angle S?
Less than.
It's less than, right. Okay, this is less than this one right here. So what do you think that means about the other side then? If this angle is smaller than this one,
CK is smaller than DH.
CK is smaller than DH, exactly right. Okay, so this one right here, we'll make that small, and we'll make this big. Do you see the difference in this? The difference was, I said that I had two equal sides and one unequal angle. Okay, so the first one said, okay, I got two pair of equal sides and one pair of unequal sides. What does that mean? It means the angles must be unequal also. This one says, all right, I got two pair of equal sides, but I'm given that my angles are unequal. What does that mean? If this angle is smaller than this one, then the side opposite the smaller angle must be smaller than the side opposite the bigger angle. Do you see the difference? All right. Let's see. So now what can we say about this? What could I say about this situation right here? I could say, let's go KC. Is that right? KC is less than what? DH. All right. So if this angle, if angle F is smaller than angle what? S, comma, then, I didn't give myself enough room, then KC is less than DH. All right? And we could call that the converse of the Hinge theorem. But I like this better. I think this explains it a little bit more. And I would stick with this one even though the book doesn't. All right? I would call it the side angle side inequality. And that's the kind of stuff they're going to give you. They're going to give you some lengths. They're going to give you some, this angle's bigger than this one or whatever it is. And they're going to ask, okay, which one is the smaller side? Which one's the bigger side? And they'll compare these. For instance, they may say this is 30 degrees. They'll say this is 60 degrees. All right? And they'll say, I don't know, this is 5. And this is that the same one? Yeah, because we just changed it. Now, because they would be equal to each other, right? And let's say, I don't know, this is 3 and this is 3. All right? So what if they give you that information right there as far as those numbers? Then what could you say about KC and DH? Well, you could say that KC is smaller than DH. Why? Because it's opposite the smaller angle. Do you see it? Well, KC is a length. KC is a length. That's an angle, 30 degrees. You can't say a line segment is 30. How do you know it's 30? No, we've never. No, you can't compare the angle to the measure of the angle to the measure of the side of the triangle, right? There's no relationship between, this is 30 and that's 30. No, this is an angle, 30 degrees. We don't know the length of this side, and in fact, at this point in your math career, we're not going to be able to find KC. Now, there is a way. As you learn some more math and you do a little bit more, you go into Algebra 2 and things like that, you're going to learn how to find actually that length of that side with this information. I bet you're excited about that, aren't you? Okay.
Extremely.
So you will be able to actually find the length of that side. Okay, it's called the law of cosines. Would be a good way to do that. Anybody hear of that?
Yeah.
Law of cosines. All right. So when you take algebra 2, you're going to learn the law of cosines, and then you're going to say, "Oh yeah, Mr. Hamrick said something about that in geometry." But we're not going to teach it in here. I just want you to know that this side is going to be smaller than this side right here. That's all you got to know. We okay with that?